Hi students, have a great day. So this is my third video for the chapter 1 of 10th standard CBSE. Up to exercise 1.1 I have covered in the first two videos. Now we are going to the exercise 1.2. So that has the fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic? This is the theorem. So in this theorem, what are the things you have to understand first? First one is composite number. So what is a composite number? You should be clear with that. So you may be knowing also, composite number is a positive integer. Any positive integer that has at least one divisor other than 1 and itself. So that means the number should have a divisor of itself. Okay, so every number is divided by itself, and every number is divided by 1, right? So apart from that, we should have some other number also which divides this number. So now here, if you take the example 6, it is of course every number is divisible by itself and every number is divisible by 1. So apart from that, there should be some other number which divides this number. So 2 divides 6 without a remainder, 3 divides 6 without a remainder. So the number which has more divisors other than 1 and itself is called composite number. Okay, so what can be done? So first is, every composite number can be expressed factorized as a product of primes. Is that or not? 6 can be factorized as a product of prime. Okay, so 6 can be written as 2 into 3 into 1. 6 is a composite number. It can be factorized as a product of primes. Up to this is the theorem, and this factorization is unique. So whatever be the method you do, you will get only 2, 3 and 1 as the factor of 6. We won't get any other number. So this factorization is unique. So after this it is over. Then apart from the order in which the prime factorization occurs. So the order, you can write it as 2, 3, 1 or 3, 2, 1 or 1, 2, 3. Only the order can be different, but the factors which are found are unique, and there can be no other factor other than the one we have found here, 2, 3 and 1, like that. For anything, the factors will be unique, only the order can be different. Suppose if I am dividing first by 3, then I can write it as 3, 2, 1 also. So the order can be changed. Okay, this is nothing but fundamental theorem of arithmetic. Okay, so hope this is clear. So next we will see the application of fundamental theorem of arithmetic. So whenever there is a theorem, there will be some application. Without any application, there is no point of any theorem. Okay, so what are the application here? We can, while factorizing, what we can find? We can find the HCF and we can find the LCM. HCF we have seen in the first exercise, and LCM you have seen in the lower classes itself. We factorize and find, right? So this is the application of fundamental theorem of arithmetic. So another one concept here is LCM of a number into HCF of a number is equal to product of the numbers. That we will see with an example now. See, here I have taken an example of 6 and 20. So find the LCM and HCF of 6 and 20. What you will do? First you will factorize 6 and then you will factorize 20. Okay, so 6 factorization is 2 into 3 and 20 factorization is 2 into 5. We can write it as 2 square into 5 also. Okay, so HCF you have already seen in first exercise. How can you find a HCF? Common factor in both. So HCF is 2. How can you find the LCM? LCM is the highest of each factor, highest power of each factor. What is the highest? What are the factors? First of all, here 2 is a factor, 3 is a factor, and 5 is a factor. So you have to find the highest power of each factor. What is the highest power of 2? 2 square. So what is the highest power of 3? 3 power 1. What is the highest power of 5? 5 power 1. So you have to multiply all the highest power of each factor so that you can find the LCM. 4 into 3 into 5, 12 into 5, 60. 60 will be the LCM here. Okay, so now what we have to prove? see, let us see this one. LCM of a number into HCF of a number is equal to product of number. Let us verify from this. What is the HCF? 2. What is the LCM? 60. The two multiplication will come to 120. For which two number you are finding the HCF and LCM? 6 and 20. So this is also 120. So the theorem is proved. HCF into LCM is equal to product of two numbers. So the theorem is proved. Okay, so it's very easy exercise. So it's like within 15 minutes you can complete the exercise by yourself also. Okay, if you have doubt you can verify in this video, and then maximum you do problems by yourself only. Understand the concept and then try to do by yourself. If the answer is wrong or something you can't understand in between, it is better to view the video and then again proceed. Okay, so then only you will get more clarity. First question, express each number as a product of its prime numbers. The first question is 140. This is all your lower classes chapter only. So just for the completion I am completing here, or else I know very well up the level of 10th standard you can do these things by yourself. Okay, so 2 into 5 into 7. You can write it as 2 square into 5 into 7 also. Right? So what is the second question? 156. So 156. Okay, 2 again 2, 3, and 13 is already a prime number, so we can't factorize further. 156 is equal to 2 into 2 into 3 into 13. Okay, so which is equal to 2 square into 3 into 13, right? So now the third question, 3825, and the ending number, last number is 5. What is the prime factor? First we will try. It is 5. So again 5 end number. So now 3. So 51. Again you can use 3. Yes, 17. 17 is a prime number, so it's done. Okay, so 3825 is equal to 5 into 5 into 3 into 3 into 17, or you can write it as 5 square into 3 square into 17. Okay, so next question is fourth question, 5005, that is done. So I have to check what is the fourth question. Okay, we have done the fourth question here, so I have to do the third question, 3825. Third question. Okay, so 3825, again the ending number is 5, so you will go for done with 384. Okay, so fourth question 5005 we have to do. Okay, fine, sorry, 5005. So fourth question only, 51001. so this 1001, 3 is possible, 3 3s are 9, 9 1 11, no, so you can take 11 9s are 99, and then 11 1, and then 91 is left out. So which number will divide 91? You can try 7, 1 and 13. Okay, so 13 is a prime number, then it is done. So 5 into 7 into 11 into 13, you can write it in the ascending order, or you can write it in the same way also. Fifth question is 7429. So finding the factor for this is little difficult, so I just have tried this and then found the factor as 17 is the first factor, and then here again 19 is the second factor, 23 is already a prime number, so this is done. 7429 is equal to 17 into 19 into 23. Yes, next question is find the LCM and HCF of the following pair of integers, and also you have to verify. So first what we have to find, you have to factorize this 26. You can factorize like this also, 13, only 2 and 13, and 91, 3, not 3, 7, 21, 7, 3. Okay, so 26 factors are 2 and 13, and 91 factors are 7 and 13. Okay, so what is HCF? You know HCF is a common factor of those. Then 13 is the HCF. What is LCM? Highest power of all the factors. So what are the factors here? 2, 7 and 13. All three are there. What is the highest power of 2? 1. What is the highest power of 7? That is also 1. What is the highest power of 13? That is also 1. So 14 into, you'll get 14 into 13. Okay, so 14 into 13, it will be, please multiply by yourself. Yes, so 12, 1, 42, 4, 1. So 182. So the LCM is equal to 182. Okay, so now we have to verify the other one. HCF into LCM is equal to product of two numbers. Okay, so HCF is, what is HCF? 13. And what is LCM? 182. What are the two numbers we are finding out? 26 and 91. So multiply this, you will get 2366. I am not showing you the multiplication steps. Please multiply by yourself. So we are getting both the sides 2366. So that means it is proved. What is proved? LCM into HCF is equal to product of the two numbers is proved. Okay. So next question is 510. When it is 0, we will go with 5. 1 0 2 2 2 51 3 7. So the factors are for 510 is 5 into 2 into 3 into 17. Okay, so for 92 it is, the factors are so 92, the factors are 2 into 2 into 23. So HCF is common factor of both, then it is 2. What is LCM? LCM is highest power. So what are the factors here? First of all, the factors are 2, 3, 5, 17 and 23. Okay, so what is the highest factor of 2? 2 power 2. Here two 2's are there, no? 2 power 2. And power of 3 is 3 power 1. And of 5 is also 1, and 17 and 23. Okay, so if you multiply all these things, you are getting 2, 3, 4, 6, 0. Please multiply by yourself. I am not showing the multiplication step here. Okay, so now what we have to verify? HCF into LCM equal to product of the two numbers, 510 into 92. So what is the value here? 46920 equal to 46920. So hence it is verified. So the next question, all are of the same method. Try by yourself. So 7 is a prime number. Done. So the factors are 336. The factors are 3 into 4 times 2 into 7. You can write it as 3 into 2 power 4 into 7 also. And then here 54 factor is 2 into 3 times 3, which is equal to 2 into 3 cube. Okay. So what is the common factor here? 2 and 3. So HCF is equal to 6. 2 into 3. Common factor is only 2 and 3. So HCF is equal to 6. LCM is equal to highest power. What is the highest power of 2? 2 power 4. What is the highest power of 3? 3 cube. And what is the highest power of 7? 7 power 1. So if you multiply all this, you are getting 3024. Okay, I am not showing the multiplication. Please multiply. Okay, so you got the HCF, you got the LCM. So what you have to prove? HCF into LCM is equal to product of two numbers. Which two numbers? Which the question is for which you are finding the HCF and LCM. So HCF is equal to 6 and LCM is equal to 3024. So multiply both sides, you are getting 18144, which is equal to, here also you are getting 18144, hence verified. So next question again the same, find the HCF and LCM by applying the prime factorization method. So this is again and again same only, there is nothing to even think. 2 into 3 into 2, you have to follow the pattern only, there is nothing to use your brain, just follow the pattern but do it correctly, that's it. So now the HCF is, what is the common factor in all three? 3. So what is LCM? So what are the factors present here? 2, 3, 5, 7. So what is the highest power of 2? 2 square. What is the highest power of 3? 3 power 1 only. And highest power of 5? 5 power 1. And highest power of 7 is 7 power 1. 4, 3, 5, 7. So if you multiply, what you will get? 60 into 7, 420. Right? Yes. So this is the LCM and this is the HCF done. So again here for 17, this is already a prime number, so it's 1 in the, this is again a prime number and this is again a prime number. So no need to brains think about what are the factors. So directly it is 1 into that number only. So why are we writing 1? Because we have to find the common factor. So here the common factor is 1, so that becomes the HCF. So for LCM you have to take all the factors highest power, so this will be the LCM. Here only the multiplication is little takes time, nothing else other than that. 11339, you are getting the answer as 11339. Okay, so next again and again same question, keep doing. 3, 25 and then 5, 5. So what is the common factor? For that we will keep 1. So the highest common factor is the common factor of all 3, which is equal to 1. So what is the LCM? Please find out what is the LCM. So highest power of 2 is 2 cube. Highest power of 3 is 3 square. Highest power of 5 is 5 square. So the value of this, if you multiply, you are getting 1800. Okay, so that's it. It's a very simple sum, very easy exercise. Just 15 minutes of your time is sufficient to complete this. So now they have given HCF and they have to find the LCM, because you know the thing, HCF into LCM is equal to product of, please write steps whenever you solve the problem. Some students will be quite intelligent and they will be in a hurry also, that they leave the steps. Okay, so if you leave the steps, then your marks will get deducted for the steps. Okay, so write HCF is given. What is given? 9. And LCM you don't know, keep it as such. And then product of two numbers, 306 into 657. So don't waste your time by multiplying this. No need to multiply. First try to cancel as much as you can, reduce that, and then you multiply. So because it's waste of time, you multiply and then will be divided by 9. Okay, so if you cut by 9, 9 3s are 27, 3, 36, 9 4s are 36, 34 into 657. It is coming to 2233. Please multiply by yourself. 2233. Don't use calculator while doing these problems, because students, for the sake of easily doing the sums and doing in a hurry, you use calculator, but of course your examination you are not allowed calculator. So always try to practice multiplying by yourself. Okay. Yeah, next question is, check whether 6 power n can end with the digit 0 for any natural number. 6 power n is given. So n is any natural number. So if I put 6 power n, it will be 6 power 1, 6. 6 square, it is 36. Likewise, you can substitute any number over here, any natural number. Okay, natural number starts from 1 to infinity. You can put any natural number over here, and we have to check, are we getting any digit which ends with 0. So first, for that what you have to do, you can't substitute each and everything and see up to infinity. Okay, so you can have a basic understanding. If a digit ends with 0, then it is obviously divisible by which prime number? 5. So whenever the digit ends with 0, that is divisible by 5. That means if this one of the factor should be 5, right? So this is vice versa. See here, if a digit ends with 0, then it is divisible by 5. So that means that number should have 5 as one of the factor. Then only it will ends with 0 and it is divisible by 5. Okay, so now if you are considering 6 power n, what are the factors? 2, like this you can write 2 into 3, 6. So you can write it as 2 power n into 3 power n. Is there any 5 in this? No. So that means no digit will end with 0. Getting or not? Sorry, end with 0. Okay, so if I am taking and see, if you can't understand, listen. See, 5 5s are 25, 0. Okay, so 5 10 5 2. I am just giving an example. So what are the factors of 250? 5 into 5 into 5 into 5, 2. So that means if 250, if 0 is there, it is always divisible by 5, and this will be one of the factor of that, then only it will be divisible. So whenever a number has to end with 0, number ends with 0, then 5 should be a factor of that. Here we are not having 5 as a factor, so it is no digit with end with 0, since the 5 is not a factor. 5 is not a factor. Okay, so you can write like this and finish this off. Okay, next one, explain why 7 into 11 into this and this number are composite numbers. So without actual multiplication, if we multiply and find the factors, then also you can find, but here we are having a plus symbol, so we can take 13 common outside. 7 into 11 plus 1, so 13 into 77 plus 1, 13 into 78. So how many factors does this have? More than 2? Yes. So if it is more than 2, then obviously this is a composite number. No need to multiply these two and then find the factors and everything. So what is a composite number? A number having factors of more factors, that is, it's divisible by itself and 1 and some other numbers also, then it is a composite number. So here we are having too many factors, then this number is already divisible by 13 also, 78 will be divisible by 17 also, like that. So it will have more factors also. So this has more than 2 factors, so this is an composite number. This is sufficient, no need for you to multiply and show that. So and here you can take, here there is a plus here, so you can take 5 outside, 7 into 6 into 4 into 3 into 2 plus 1. So here again you don't have to multiply 5. So if you are multiplying this, you are getting 1008 plus 1, so 5 into 1009. So that means this has more than 2 factors. So this is a composite number, right? Okay, so don't waste your time, because in your 3 hours paper you have many tough sums. These are all, so you have to do the sums smartly and as per the requirement of the question. Okay, don't multiply all this, find the factors and then say it is a composite number. Okay, so next question is, there is a circular path and Sonia takes 18 minutes to drive 1 round. Suppose this is the starting point, so take 1 round, she takes 18 minutes. So while Ravi take 12 minutes. Okay, so this is of Ravi. Ravi thoda jaldi bhagta hai, that is he runs little fast or he moves little fast than Sonia. So there is a 6 minutes difference in their completion. Okay, so what is the question then? Suppose they start at the same point. Okay, so their starting point is same and at the same time. Okay, so then go in the same direction, that is they start at the same time here, like your sports running race. So if the whistle goes and all of you will start running, no, like that. They start at the same place, they start at the same time and they go in the same direction. Okay, after how many minutes they will meet again at the starting point? So here they have to meet again. So 18 minutes she is coming here, So 12 minutes he is coming here. By 18 minutes he will be somewhere over here. He won't meet her, right? So first round when she is completing, Ravi will be somewhere over here. Okay. So first round she completes by 18 minutes, Sonia, and then Ravi completes by 12 minutes. What is the next round? She completes by 36 minutes. Ravi completes in 24 minutes. That means again they won't meet. So next round Ravi completes by 36 minutes. So he will meet Sonia at third round. Okay. This is just for your understanding. I'm explaining the question. In your problem, you can find the LCM of these two so that you can easily find out. 3 into 2 into 3, right? 9 2s are 18. 2 into 2 into 3. Okay, so this is the thing for the factors for this. So 18 and 12. Okay, so LCM is, what is the highest power of 2? 2 square. What is the highest power of 3? 3 square. So 4 into 9, which is equal to 36. So what is 36? We have to write. So when we are studying, they will ask if there is a no unit, no, our professors ask whether it is a donkey or monkey. Okay, so without unit there is no meaning for here. So you have to see the sum. They take 18 minutes. So this is 36 minutes. After 36 minutes, you have to complete the question as after 36 minutes, they both will meet at the starting point. At the starting point. Okay, so that's it. So can you understand this? I have explained you verbally, like logically you can understand. First round she completes by 18, and then second round she completes by 36. At 36 minutes she will be at this point. So but Ravi will be at 36 minutes, he will be at this point after third round. First round he comes here 12, and then second round he comes here 24, and third round he comes here 36. So during his third round and during her second round they will be at the same place. Okay, is this clear? This is a very easy chapter, only just a little bit of calculation you should do properly without any errors. Okay, so see you students, bye now. I'll meet you in my next video.